All right, so the live streaming is going. It looks like we're good. So yeah, it looks like we're ready to go. Sam, whenever you're ready, I think we can get
Sure.
started.
Yeah. I mean, I'll just introduce that. I mean, because my name is on the first slide here, so I put yours on it. I'm Sam Dillard. I'm a product manager with PingCap or TiDB, and I'm responsible for the SQL layer, so all the sort of functionality that you deal with in the dealing with SQL and adding in an index and doing DML and other things like that. And I'm also loosely overseeing other parts of the cluster as well. So if you're in the community and you want to ping me in our Slack channel, that please do that. I'm happy to answer questions or route you to the right person or something like that within that community. And then of course I'm with my colleague Ray, who I'll let you introduce yourself, Ray,
Yeah,
and move into the slides that you have here.
cool. Thanks, Sam. Yeah, my name is Ray Pake. I'm a community manager at PingCap. I'm happy to facilitate this last virtual meetup of the year. We're getting close to the holidays, but we just had an exciting, stable release launch a few weeks ago. Happy to have Sam here. A couple of logistical items. This virtual meetup. If you're on Zoom, you'll see the Q&A tab at the bottom of your screen. Whenever you have any questions while Sam is presenting, I think, Sam, you dedicated some time towards the end for Q&A, but we can take care of questions as they come along as well. And rather than using the chat function, the Q&A tab allows us to keep a log of all the questions that came in. So for example, if we need to improve our documentation, for example, it's a good data to have that we can forward to our Doc's team or other team members. And then secondly, the recording will be posted. This is being live streamed on our YouTube channel that you can see the QR code there if you haven't seen our meetup playlist. So you don't need to like furiously take notes or take images of the slides that will be, you'll be able to rewatch them at the end of the presentation. And Sam, we can move on to the next slide. Yeah, and just wanted to give people a heads up on an exciting community event we have coming in shortly after the holidays. Starts on January 9th. Um, the event is called DocStash. I mentioned documentation earlier. This is something that, as an open source project, that we put a lot of effort on. But we'd love to get our community members to contribute to improving our documentation. This is going to be a fun hackathon type of event that's going to go for 3 days, and we'll have a couple of weeks to sort of review and merge like PRs or review some of the issues that you open. It's going to be fun. We'll have some fun swag, and we'll also award some virtual badges to people that participate. So take a look at the event page. Again, there is a shortened URL there along with the QR code. Take a look at the event. We'll have a lot more information there along with the blog posts and podcasts that we did in anticipation of this event. So hope to see many of you there. And thanks, Sam, for letting me sneak in a couple of announcements. And I'll turn things over to you.
You bet. Can PMs attend this event?
Oh, yeah. Oh,
Yeah.
yes.
Cool.
Well, you might be asked to review some PRs that come in too. So,
That's fair. Yeah.
yeah.
Okay. So the agenda for this presentation is fairly simple. I'm going to just give a little, hopefully brief intro of TiDB for those who are not familiar. I imagine if you're here, you're probably familiar with TiDB, but maybe just hearing me say it a different way than you've heard it before might help. I don't know, but I will give you a brief intro about TiDB because I feel like that's relevant to what we're going to cover after that, which is highlights of the releases between 7.1 and 7.5. So the way this works, I described this in our last webinar in mid 2023, but the way our release cadence works is we have two stable releases every year, usually in mid of a year and end of a year. And so this webinar is about the 7.5 release that was released in early December. And what it is a culmination of the differences between 7.1 and 7.5, which includes the milestone releases 7.2, 3, and 4, and 7.5. So this is really about 4 releases, but Most of our customers and our users use the stable releases only, so we're combining them all into one. And then we'll anytime for Q&A, we'll have, I'm sure we'll have time at the end for that. So TiDB, if you are not familiar with this, the reason that TiDB exists really is fundamentally and originally to bring the idea of scale back into the world of relational databases, whereas, relational databases that most people are familiar with are traditionally monolithic, and they eventually topped out with regard to scale unless you do sharding with them. So for the last couple of decades, NoSQL gained popularity because of the burgeoning of application data, the size of application data. So if you didn't have strong ACID requirements in your application, NoSQL was a really good choice. It was a favorable choice for scale and being able to grow the scale of your application. TiDB's goal is to kind of bring that back into the fold for relational databases. Without sharding, you can achieve the same scale as NoSQL databases with a SQL database now, or an SQL database. So that's TiDB's number one goal. And then, of course, there's other goals that are downstream of that. To do that, and this is a very, very, very abstract slide here, but TiDB is architecturally disaggregated in that it has its compute, storage, and sort of its brain, the scheduler and the coordinator, all separate. They're different processes, and they can be run on physically different hosts. What this allows for TiDB to do is be more stable on the compute and storage layers. So the compute and the storage do not interfere with each other nearly as much as they would if they were coupled. And it allows them to scale independently of one another, making resource usage much more efficient, especially when your cluster is very, very large. And some of our customers' clusters are indeed very, very large. What it looks like in more detail here is this. So the compute layer is TiDB server, the namesake. That server is dedicated to handling the SQL requests. So it parses and tokenizes them, and then creates logical and then physical execution plans for how it will gain access to data in storage, and then how it will compute that data. And that data is stored in TiKV. Where the data is stored that metadata is stored in PD, which is called the placement driver. So that's the brain I was talking about. Placement driver stores the metadata about where data is located in the cluster. It does a whole bunch of other things too, like transaction coordination and stuff like that, but I'm not going to go into that right now. The compute layer will send requests, break up requests, and send them down to TiKV storage nodes. You might have 200 TiKV storage nodes that each have hundreds of thousands of these key ranges in them. TiDB knows where these key ranges are and sends requests for access to data, and even pushes down some functions for aggregations and things like that to TiKV. Now, TiKV, this is really important. The key ranges that we call regions internally, but externally it just makes more sense to call them ranges. These are about 100 megabyte size by default. They can change if you merge and split them, but these are the ranges are basically 3 members of a replica group that is replicated via the raft protocol. So these are raft groups. Because each range and its members, or its replicas, are their own raft group, they each have a leader, which means that we can have strong consistency while writing to multiple leaders at the same time. So part of, not only can you store a lot of data in TiDB, but TiDB's architecture is also fundamentally multi-master write. So you can scatter reads and writes to many different ranges of data all at the same time, which is something that your traditional monolithic relational databases could not do. So this is kind of a fundamental attribute of TiDB that allows for it to sort of compete in the NoSQL space. And if you want to know more about these design choices, this is really fundamentally based off of the Google Spanner architecture. So you can read that paper if you want to nerd out on why we made some of these calls. So onto the release. Again, this is the difference, the delta between 7.1 and 7.5. So at a very high level, these 4 features are what I'll talk about the most. There's going to be other ones in here, but these 4 things that I kind of just drew conceptually here. The first is these DDL nodes. I call them DDL nodes. Really, they're designating nodes for background work, and I'll talk about that in more detail. Runaway queries being caught. This is sort of like a database level SQL block list in a way where you can catch these potentially bad queries and do something with them, and that something is configurable. Data will also be globally sorted when doing large data reorganization tasks. I'll talk about that in more detail and why it's such a huge benefit. And then background tasks like DDL and import and analyze and things have also been given support for resource control, so they can be throttled, make them run slower, but also affect foreground critical traffic far less or not at all. So those are the four main things that show up in this release, along with some others that I'll talk about in less depth. So as the theme, right? It's all about scale fundamentally, but scale is not the only thing we care about. You can't justify scale if you don't have other things, right? So scale begets. So the first thing we want to think about with scale is how we got to scale, and that is the architecture. And how do we leverage the architecture to improve on performance and stability and other experiences you might have with a cluster. So this release, sort of first and foremost, leverages the architecture of TiDB to improve on the overall experience of using it. And then secondly, when you have a scaling database, we also, in some cases, want to justify that scale. So you may not have a single workload that justifies needing to have a distributed SQL database underneath it, but we want to start combining workloads into the same scale, into the same cluster, to improve on operability, right? To make it so you don't have to shard across multiple clusters even. So we want a single cluster to be able to handle most of, if not all of your workloads, your transactional workloads. But with doing that, we add this noisy neighbor problem that you're probably familiar with. So 7.1 and 7.5 all have features to kind of mitigate this noisy neighbor issue. So the first thing here is with regard to leveraging the architecture. In 7.2, we introduced the distributed execution framework. This is a foundational framework in the cluster that applies to really any kind of large background task that can that you could initialize in TiDB, or that TiDB initializes on its own. And over time, we're going to start adding more to these. Right now, we've got a few that apply to the distributed execution framework. More will be added in the next few months and quarters. But what this is it takes the original execution framework and allows TiDB to intelligently split up the work into subtasks, into sub-workers, and distribute the work across TiDB nodes. And what that does is two things. One is it drastically improves performance of these tasks. So by parallelizing it far more, the work just gets done far quicker. But secondly, it more uniformly distributes the work across TiDB nodes, allowing for a lower exposure to saturation of a single TiDB node. So far fewer out of memory errors with TiDB, far less CPU saturation and whatnot. So this is a stability and a performance feature. But the third thing is that it actually allows us to do a whole bunch of other stuff downstream of that. So the first feature that sort of builds on this distributed execution framework is the idea of global sort. So I'll describe what's in this image in a second, but I want to talk about the problem it's solving first. So when you have when you're doing data organization tasks at all in the database like this, there's going to be some level of sorting that's happening on that data set. Whether you're doing an add index and scanning data from TiKV, organizing it and sorting it, and then creating an index out of that and storing that index back in storage, or you're doing imports or whatever, right? These are all involve some amount of sorting of the entire data set. If you're distributing that sorting, you're speeding up the sorting, but you're also scattering the sort of global nature of the sorting such that each bit of sorting that happens is not necessarily going to be ordered with respect to one another. So each batch that's sorted will be overlapping, almost guaranteed to have a lot of overlap. Historically, when you have this overlap, and TiDB Lightning, if you're familiar with that, it's the import tool. When you're doing physical import, TiDB Lightning would do this sorting, and it would store the basically intermediate sorted results into TiKV, and TiKV would have to merge sort through compactions, basically do the final sorting of this data. That is a very expensive operation for TiKV. So by globally sorting at the TiDB level before storing it into TiKV, TiKV no longer has to incur this huge I/O amplification, enormous CPU and memory spikes. It no longer has to do any of that. TiDB can handle this all on its own. By using the distributed execution framework, we can leverage TiDB's distribution and a single shared external storage like S3 or S3 compatible. We will eventually support GCS and Google as well, and others in the future. What this feature does is, like normal, like before, it does batch sorting, breaks up a bunch of batch sorting tasks across TiDB nodes, does the batch sorting. Those batches that are sorted are stored intermittently into this shared storage, and other TiDB nodes or other workers on the same TiDB nodes are then assigned to do merge sorting. So with those sorted batches are these stats files that basically tell the other workers how to sort the data across sorted files. So you're just basically doing this federated tree-like sorting, merge sorting of data across the entire data set that you're organizing. And once it's completely sorted, TiDB will then load these sorted files into TiKV. TiKV then only has to create the SST files from that. So TiKV is no longer doing this merge sorting, and it's drastically reducing the amount of instability TiKV may have otherwise felt when doing imports or add indexes and things like that, assuming you're not isolating that work some other way, which we will also talk about. So this is a huge benefit to stability here. Also a user experience. And then for the last leveraging the architecture feature is designating nodes for background tasks. This is the DDL node I was talking about. So because of the distributed execution framework and its sort of intelligence, its dispatcher inside, you can label TiDB nodes for background work. So the distributed execution framework will then only apply to those nodes. When a node is labeled as a background node, only those nodes will get background work, distributed execution work, and they will get no DML work. And they will get no foreground traffic work. And then on the flip side, the non-labeled nodes will also get no background work. They'll only get the DML work, right? So if you have a cluster of TiDB nodes, you can cordon off the compute for background tasks this way. And probably even more importantly, if you have these ad hoc tasks you want to run, like an add index on a very, very large table, which could take hours, right? Maybe even more than a day, depends on really how big your table is. But you can add TiDB nodes because they're stateless. You can just sort of append them to the TiDB cluster and label them as background work, as background nodes, and run that add index on those nodes only, and then spin them down when you're done. So, it adds to stability, to its cost savings. It's just an overall much better experience when you do this. So moving to the mitigating the noisy neighbors theme. In 7.1, I talked about resource control already. That was released in 7.1, but we've added on to this sort of foundation that we laid then. But I'm going to briefly talk about that just so that you have that background today. So resource control is basically very high level is this diagram is probably maybe a little bit of an eyesore, and I'm sorry for that. But basically, it's you create a resource group and you assign entities or users or sessions, basically workloads of a classification you define to a resource group that has a limit of resources it can use per second and a priority setting. So you can give high priority applications or workloads, a higher priority and more resources. You can even make that burstable so that it can use any available resources at the time. By giving it a higher priority, when the requests from TiDB are sent to storage, and there's any saturation in storage that leads to any kind of queuing of tasks in TiKV, the high priority tasks for the high priority workloads will cut in line and be executed first. So this means that under saturation and cluster saturation, and when storage is backed up even a little bit, your highly critical, the strict SLA applications are still achieving their low latency. There's a stable low latency there because they're getting executed in front of the lower priority workloads. So So this is really important for mitigating noisy neighbor issues. And of course, in the bottom there, we see background tasks. This is that background process stuff that's being added to resource control is actually new in 7.5. But what we've added is the stuff in bold here. So I described already the first two bullet points. The third is that, you have observability about resource groups. You can understand how they're being used, how they should probably change over time based on their workloads changing and things like that. But what's in bold is what we've added in 7.5, and I'll talk about this in a second. Catching these long running or what we call runaway queries is helpful within a resource group. So the resource control feature itself helps noisy neighbors across resource groups, right? One workload doesn't interfere with another workload. But even within workloads, we have some bad actors sometimes. We need to figure out a way to deal with those bad actors. And then the last thing is, of course, background tasks. Simply put, we just added the ability for you to throttle background work into a lower priority resource group. But let's talk about the long running queries. So when at the resource group level, and this matters because you can set these rules for different queries based on the type of workload they're inside of. So doing it at the resource group level makes sense. What we do here is we set a rule in the resource group to identify queries based on how long they run. So if you say that 5 seconds is too long for a query to run in this resource group, you can set a threshold of greater than or equal to 5 seconds. What that means is any query that comes in that runs for 5 or more seconds, or for 5 seconds, it will be marked as a quote unquote runaway query. When that's marked as a runaway query, an action will be taken on it, and the resource group will continue to watch for subsequent queries that are either exactly the same or have the same plan digest. And there's trade-offs for which you choose there, and I won't go into it here, but that's all documented. And then you can choose when you identify further runaway queries that match the first runaway query, you can take some action on all of them. And anytime there's a new query that's identified as runaway, you can either kill it and have it cascadingly canceled across the cluster, and then a error sent back to the client saying that it was marked as a runaway. Or you can cool it down, which means it'll still execute, but it'll execute slower and it won't interfere with more critical traffic. So this means that even within a resource group, if you've got a query, if you have some queries that are kind of quote unquote bad actors, you can prevent them from using up all the resources in the resource group or the priority by sort of deferring them if they for deferral. The one problem with this still, the one problem remaining is that you actually have to wait for that first query to execute. What we want to do is try to prevent any one of these queries from executing at all, even for that first 5 seconds. Sometimes people will set 60 seconds, which means you have to wait for the first query to run for 60 seconds. So if you know what queries you want to kind of block, an SQL block list already, you can manually add these watchers so that you never have to let these queries execute at all. So between the two of these methods, you can pretty much catch most of the situations where you'd have a bad query running inside of a resource group, or at least hogging resources. So that's it for the high level themes. This is the rest of what was in the release. So this is, they're not less important, but they are far smaller features, I think. With regard to stability, we've talked about this. We've added background resource control. That's fairly self-explanatory. I didn't talk about this yet, but TiFlash is the alternative storage engine that it can be used as a complement to the row storage engine. It is a columnar storage engine, which allows for faster analytical queries, more complex join queries, scanning columns that are not indexed more quickly, more efficiently. So TiDB, being aware of both TiKV and TiFlash, allows it to choose based on generate execution plans that choose row-oriented storage or columnar-oriented storage based on the specific subtask that the query needs to accomplish. So that's TiFlash. These two features are really important because the first one, storage compute decoupling, means that just like with TiDB itself, we've disaggregated storage from compute, which means that you can scale storage and compute independently of one another, which is a better use of resources. It also means compute becomes more stateless, right? And then by decoupling storage from it, we've also allowed you to store the more archival or the colder data into object storage, making storage a lot cheaper. One of the prohibitive portions or parts of TiFlash is that it's a more expensive thing to add on to your cluster. So we want to make sure the storage was a lot cheaper. And then query spill to disk essentially is it's a trade-off where you kind of slow down your query a little bit, but it adds to memory stability of TiFlash. So if you have a lot of concurrent queries coming in, or ad hoc very large queries coming in that are super analytical in nature, your exposure to an out of memory issue with TiFlash is higher. So if you spill to disk instead, as the query is executing, you add to stability with a small hit to latency. But in a lot of cases, these analytical queries don't have the same kind of latency requirements as the transactional queries. So this is a really nice optional configuration for TiFlash. TiKV level timeout propagation essentially is meant for clusters that have very, very strict SLA requirements and also allow for follower or stale reads, meaning that their SLAs for latency are so strict that they actually want to read from replicas, and they're willing to take the trade-offs to do that. TiKV level timeout means that before the sort of client level or TiDB level timeouts are engaged, TiKV can notice when it needs to time out and let TiDB server retry on a different TiKV node. And this is really important for situations where like the underlying infrastructure, say an EBS volume, is being throttled or is experiencing some amount of jitter, and you have a timeout at TiKV that's maybe 500 milliseconds. If TiKV, if you know your queries are supposed to be complete in under 200 milliseconds, for instance, if it hits 500 milliseconds, we know that TiKV is experiencing some kind of issue. TiKV will then propagate an error up to the TiDB TiKV client, and that TiKV client will redirect the request, the subtask of the query, to a different TiKV node. That way, you ultimately finish the query sooner. So your TiDB is not waiting for a throttled TiKV node to finish an entire query. From an operability standpoint, the import into feature is one of the biggest features here. It's really, really cool, and it's another one that's built or downstream of the distributed execution framework and the global sort feature. So if you're a TiDB user today, you're familiar probably with TiDB Lightning and how it has both a logical and a physical import mode. What this feature is bringing in the file system level import mode, which is the faster import mode, into TiDB itself, so that you can do the import into from the SQL layer, like with the SQL interface itself. This has a ton of benefits besides just user experience. The first is that TiDB can, you're operating in the SQL interface, and it can go out and find those files for you. You have to give it the endpoint, but it can go reach out to remote storage places like S3 and find your CSV files or your SQL format files and bring those in for import. Another huge benefit of it is that, unlike TiDB Lightning, where you had to manually chunk or slice up your incoming files to load them into each individual TiDB Lightning node, TiDB, using the distributed execution framework, will do this for you intelligently. So it'll take what it knows about the cluster, and it'll split up your source files such that each TiDB node is roughly uniformly distributing that work and sorting that stuff. And because of the global sorting, when it's writing the data to TiKV eventually, it's obviously you're going to experience far less amplification of I/O, CPU, and memory usage. Excuse me. So the import into feature is a convenience feature in multiple ways, and also takes advantage of the distributed and nature and the global sort feature to add to stability in a big way. So that's really important, and eventually that will turn into we'll have import into for the logical import of TiDB Lightning as well. But right now it's just the physical import. Pausing and resuming DDL is really important because in other database engines, you either have to cancel DDL outright or you're unable to cancel them at all. So if you're running a very long add index operation, for instance, and you need to do an urgent upgrade, Well, that upgrade isn't, you can't do that upgrade, right? Or you have to cancel the operation and start it all over. If maybe it's been running for 10 hours, you have to start those 10 hours over. If you have a large ad index operation going or an import operation going and traffic is peaking and you notice that both of these things can't really run at the same time and still deliver on your application's SLAs, you can now pause the background task and let the kind of high traffic period run its course and then resume later when there's resources available. So that's a really important operational feature. This one is smaller, but it's really important for some of our customers where some of the queries within a workload, every once in a while or even constantly need their own configuration. So being able to granularly set system level configurations at runtime of a query is really important, right? So being able to override a system variable in the query itself with a hint of set var allows you to do things like increase or decrease the maximum concurrency, the allowable concurrency of a query during the run of that query only. And then of course the system variable will return to normal as that when that query finishes. When you have table stats, right? If you don't know, TiDB is sort of on an interval, kind of continuously analyzing tables to collect stats on it so that the optimizer can choose the best plans possible for queries to reduce latency. Sometimes the analyze job is becoming very expensive and you don't want to be doing analyze because your queries are running okay already. Or the analyze job is actually kind of skewing your plans a little bit for whatever reason. You can lock the stats to prevent the analyze from happening so that your foreground traffic can be freed up. And also just locking in good performance, right? If you have good performance, don't fix what's not broken. So in a lot of cases, people will lock stats. So you're not updating the stats. Of course, you probably eventually will see some drift. You can simply unlock stats and have the analyze run over again, and then you can lock them again if the plans are being chosen correctly. So that's that feature. The optimizer mode is kind of a similar but different way of handling stats. Optimizer mode, the default is a moderate mode, which is doing what you know already. There's another mode called determinate mode, which basically means when we're creating plans, we will use the static statistics, so the stuff that is being analyzed, but we will not use the runtime statistics. So this is sort of a halfway between the lock stats, which is basically saying we'll use the stats, but only as they're static, and we will not use runtime stats, which may skew the plans chosen for whatever reason as well. So these are operational procedures that you can do to kind of better enforce the plans being chosen that you already like. From a performance standpoint, we have a push down of the JSON member of function. So this basically when you're checking for the membership of a value in a JSON array using like the multi-value index, for instance, you can push this function down to TiKV and TiFlash, which obviously adds to performance and reduces the data transfer over the network between storage and compute. The session level general plan cache is kind of a mouthful, but our plan cache originally was only for prepared statements, which it's kind of a default thing when you're using Java, but generally, if you want a plan cache for any kind of statement that's not prepared, that's what this is for. And this is, just note, this is on the session level. So you will have the same cached plan across sessions, even if if it's the same query, as long as they're across sessions. So that's in the future, we'll actually have instance level plan cache, which will reduce memory usage. But for now, it's session level. There's trade-offs there. So there are benefits to having it be at session level. But for now, this is what that is, but it's more flexible than it used to be because non-prepared statements are now compatible with this. From the observability standpoint, we have TiKV got continuous heap profiling. Prior to this, TiKV, you had to kind of SSH into TiKV, download and install a couple tools to take a profile, and you kind of had to do the profile during. Well, you want to do a profile during the moment that you're of interest, right? When you're doing manual profiling, you kind of have to either wait for that moment of interest or force that moment of interest to get an accurate profile for when you experienced a problem. When you take continuous profiling, you're much more likely to have profile data already on hand what during a period of interest. So that's one benefit. The second benefit is that we have a UI for you also, that this TiKV will load these heat profiles into the UI so that you can see a dashboard of continuous heat profiling for TiKV based on time. So you can say, okay, we ran into this issue in TiKV on this node. Let's drill down to this node, find the heat profile for that time period, and look at it, and then figure out what may have gone wrong. Show analyze status. This gives you an ability to look at a snapshot of the status of the data of the statistics collections happening on a table. So you can say show analyze status for a table. You can figure out how much progress the analyzed job has gone through. You can and other metadata around that job. As far as the ecosystem, we've added a sort of an experimental or prototype service called an index advisor, which essentially uses schema information in TiDB and table stats and creates these sort of hypothetical indexes and runs and basically kind of does query planning outside of TiDB and then suggests for you indexes to add to improve performance or even indexes to drop that are not being used. So that's what the index advisor is for. And we really encourage people to try this out, see if it's sort of a helpful tool for them. It's prototype right now, so it's accepting tons of requests. We may even bring this into TiDB or some of these features into TiDB directly as well, instead of having it run as a separate runtime. And then lastly, we have we added an output to Pulsar from TiCDC. So Pulsar is obviously a sort of a substitute for Kafka in many ways. And then we've improved upon the output to Kafka such that Kafka has a value size limit that's, I think, you can't even change that, I think. But regardless, if you can, you don't have to change that. TiCDC, if you're writing data that has values that break that limit, TiCDC will recognize that and store that value somewhere else, like in object storage, and tell you where it is so you can go find it. And so it doesn't interrupt the output to Kafka just because you had one value that breaks that threshold in Kafka. And that is it. So that's the 7.5 release. Hopefully there's some stuff in there that was exciting for our users. Not everything is going to apply to everyone's experiences, but hopefully that was comprehensive enough, and that you took away what I wanted you to take away from it, which was those key features having to do with scale and the distribution of work across the nodes and being able to mitigate the impacts on foreground work with background work, essentially. And with that, I'll take questions.
All right. Thank you, Sam. So monitoring both YouTube live stream and Zoom for questions. Looks like we have a couple here. The first question is, are any of the features or themes that you talked about, are they applicable to cloud only, or is it available for open source users as well?
Yeah, this is everything I mentioned in this is the core kernel of the database. So this will apply naturally to all offerings, to serverless, dedicated cloud, and the self-hosted on-premise version.
Right. Cool. All right. So, and the next question is, can you share any information about the next stable release? I think you talked about this coming up in the middle of the year. Like anything you were excited about, or anything you can mention about what you're planning to do in 2024?
Yeah, I can. So there's actually a fairly big feature that's coming out. That's actually 2/3 built already. And I was considering even including that in this because it's work that we did and is done before 7.5, but I actually stored it here in an appendix. So I'll show that in case this question was asked. And so, but before I show it, I guess this is sort of a problem slide. So if you are using TiDB at enormous scales, this is another scale theme. TiDB has a bottleneck currently for very, very, very large clusters, right? Like we're talking 500 plus terabyte clusters, sometimes upwards of a petabyte. That bottleneck is the brain I was talking about, the PD, placement driver. And for various reasons, that placement driver is kind of like a single point of failure, where if you're If you have very high QPS, it's requesting transaction IDs from PD all the time. So that's the TSO service there that you see in the image. So if that service is being hit too hard, that means that all of the other services, because this is all coupled in the same process, all those other services can be hindered, right? And the same is for heartbeats. If you have an enormous cluster, each of those key ranges I was talking about, all all regularly send heartbeats and with information to back to PD. And if PD is being overloaded with too many heartbeats, that's also going to saturate its CPU and potentially the node. And when you a node or out of memory node, you kill a node of PD, you kill the leader of PD, which means that really, long story short, no request can be served for a couple seconds while a new leader is chosen. And a couple seconds of outage is actually fairly costly, especially for these large clusters. So this feature, which actually has been largely built today, but it's not ready for production use, is to disaggregate. This is a big theme, disaggregation. Disaggregate and sort of modularize all of these functions of the placement driver. So TSO and the heartbeats and the admission control, all separate services that sort of report to a core API that continues to use the leader follower model. But the benefit of it is that if TSO is overloaded or heartbeats is overloaded, it doesn't overload the core API of PD, so PD continues to serve other functions. So this feature is designed to let TiDB scale far further, and help reduce latency, timeouts, and QPS throughput issues when you're achieving that scale. So these benefits are, I should have switched slides earlier, but this is what that basically looks like, is sort of separating out each of those services into their own little primary and follower clusters. The only thing here that uses Raft in the leader election is the core. So when you lose core, it takes longer to come back, but what we're doing here is drastically reducing the exposure to failure of the core by separating out these problem spaces. The TSO and the scheduler and the admission control and the heartbeat system are all potential problem spaces for the core. So separating them out just reduces or increases fault tolerance essentially. So that's number one. That's the big one that's coming. That this is going to add. We may experience doubling of the upper bound of scale for a cluster, which would be really, really exciting. And we'll obviously announce that kind of thing if that becomes true in the middle half of next year. But there's other things that we're considering. We have on our minds. It may not be released by mid next year, but things that we're considering are like new indexes, like bitmap or inverted indexes for full text search or materialized views. And what we'd like to know from you guys is what you're waiting for, right? So every single person who has a request is a data point for me and my team to prioritize or reprioritize things and get them in. So the roadmap for June is not set in stone. So we can absolutely add in important things if we get enough traction.
Cool, thanks. I just added a link in case people aren't aware. In our documentation, we have a roadmap section, both for TiDB and TiDB Cloud. And at a high level, I think the product team talks about what you're planning to do going forward over the next few quarters. And then I think you're able to open issues to ask questions as well through GitHub or open a pull request. So that's another way to sort of interact with us. So I just pasted a link here on Zoom, and I'll do the same thing on the live stream as well. Cool. I'm scanning for last minute questions on live stream. For people on Zoom, if you have any questions, feel free to type them in the Q&A tab, and we'll be happy to answer them. Right, I'm going to give it 10 more seconds here. It looks like everything's crystal clear, Sam. So,
right on.
Cool. So yeah, and then obviously we started doing this, back when we released 7.1. So hope to continue this tradition going, not only to interact with people through during the virtual meetup, but I mean I think it's been a pretty valuable content on YouTube as well for people to learn more about our stable releases. So, oh, looks like there is a question. So any major security changes on the roadmap? Not sure if you need more details, Sam, but that's the question that just came in.
No, yeah, it's fairly clear. So there's a couple different angles to answer that from. One is I didn't mention this, but I am responsible kind of solely for the self-hosted stuff. So there's definitely going to be security patches and roadmap features in the cloud, like dedicated cloud and the serverless cloud. That's it's obviously very important in cloud. And I don't have a lot of information on that personally. This is more about the kernel. This whole release is about the kernel features that apply to all of the offerings. As far as security related to the kernel, there's a big enhancement that was actually part of 7.5. The work we did in the last 6 months was we having third party penetration tests at the code level. So for stable releases, we want to be having an objective third party do vulnerability scans of the code, and finding any possible backdoors and stuff like that to improve on the confidence that people have in using TiDB, whether they're using it in production or not. And so that's a big change that we've made here. I'm not sure. I don't personally have a lot of details on that and how it would be messaged to the community, but know that we're doing that, and hopefully we'll have some external messaging about it shortly.
Cool. Let's see. I think there's one more.
Comment looks like.
Oh, it looks like a comment. Not. Thank you, Rohit. And then, yeah, thanks for all the questions that came in. And then for the security question, if you need a follow up, feel free to ping me or Sam on our community Slack, and we'll be happy to either try to answer them or get somebody smarter than us to get back to you. So cool.
Right
Yeah, it
on.
looks like we're all set. So, I mean, thanks all for joining, and thank you, Sam, for presenting again. And hope everyone has a great holiday season. And we'll see you in the new year in 2024.